Hello, welcome to join the talk. Today I'm going to talk about setting up a monitoring system for Alluxio with Prometheus and Grafana in short time. Firstly, I'd like to introduce myself. My name is Pan. I'm now working for Tencent. Recently, I'm working on Presto on Alluxio, so I'm really glad to share our experience about Alluxio. So there will be three parts of my talk. Before introducing the monitoring, I'd like to talk about the Alluxio metrics system and Alluxio Sinks, especially how to implement the custom sink of Alluxio. Okay, let's start the first part, how Alluxio metrics system works. I listed some key points of Alluxio metrics system, which I think can help us to understand how Alluxio metrics system works. The first is the framework. This is the Alluxio metric system framework. The metrics are generated by different sources and then be consumed by sinks. The metric system pulls sources periodically and pass the metrics records to sinks. And Alluxio supports many kinds of things, which I will introduce later. There are two types of metrics. One is the cluster metrics. A cluster metrics is aggregated from workers and clients, then calculated by the data master. The cluster metrics provides a snapshot of the cluster, of the Alluxio cluster. That is the cluster metrics. Another type is process metrics, which is collected by each Alluxio process. So there will be master metrics, worker metrics, and client metrics. Because we will use these metrics to set up our monitoring, so it's important to figure out how these metrics are named. In general, metrics of Alluxio follow two name pattern. The first is for the master metrics. A master metric consists of master and the metric name and some tags. This is an example of this type. It's get field information operations. There's no tags here, so the tag is optional. The second type is for non-master metrics. For example, the cluster master or the worker cluster is combined by the process type, the metrics name, and the tags and the host name. For example, this is the open existing field metric for workers. So the process type is worker, and the metric name is open existing field, followed by three tags: user, the UFS location, and the UFS type. And the last part is the host name of the worker. Okay, this is how metrics named. Another point I think we could focus on is the flow of metrics. Since the master needs to collect metrics from workers and clients to calculate the cluster metrics, so the client and the workers need to report their metrics to the master. This diagram shows the flow of metrics from worker to master. Workers and clients send the metrics data to Alluxio master through heartbeats. The block on the right is the worker process, which left is a master process. That's from right to left. The heartbeat process is under control of the block master sink, and the metrics and other information about the worker are passed to the RPC client. Then the RPC server receives the heartbeat and process the metrics from workers by a metric master. The metrics are stored in a metrics store and will be aggregated and calculated later. So this is how metrics flow from worker to master. Metrics from client are handled in a similar way. Okay, This is the first part. It's only a brief introduction of Alluxio metric system. If you are interested in this part, I recommend you to read the Alluxio code, which is much clearer and easy to understand. Okay, let's move on to the next part, Alluxio Sinks. In fact, Alluxio supports many kinds of things. A sink specifies where metrics are delivered to. For example, Alluxio has the HTTP JSON sink, and it's enabled by default. So we can view dashboards of metrics in Alluxio Web UI from the JSON format. This is the JSON sink. In addition to these existing things, Alluxio provides a convenient and flexible sync interface for developers and users to implement their own sync. So in this part, I will give you an introduction of different kinds of Alluxio syncs, and then I'll show you how to implement a custom sync. These are the things Alluxio supports. For example, the console sync, the CSV sync, and the Prometheus sync. They all implement the sync interface. It's a base interface. So in general, these syncs can be divided into two kinds, the passive sync and the active sync. The difference between these two kinds of syncs is the way we get the metrics. I'll give you some examples to figure out the difference between these two kinds. Okay, on the left is the console sync. If we enable the console sync, the metrics will be printed into standard output file. For example, the master out or the worker out. The console sync reports the metrics periodically, so you can get the metrics anytime you want. So from the Alluxio's perspective, it's active. On the contrary, the right half is the HTTP JSON sync. It's a passive sync. A passive sync works as a service, so only when we send a request to the server, we can get the metrics. For example, if we access the metrics JSON location of the Alluxio web server, we can get the following metrics. It's in a JSON format. So it's a passive sync from perspective of Alluxio. Also, I'd like to briefly introduce how these two kinds of things work. This is the structure of console sync. We can find the console reporter in the console sync. It's a scheduled report which can report the metrics periodically. In the report method of the scheduled reporter, we can see that different types of metrics are printed in a specific format. So this is the console sync. Next is the Prometheus sync. The Prometheus sync works in a totally different way. There's no schedule reporter to report the metrics, so we need to get the metrics by ourselves. The passive sync need to implement a get handler method, so the master and the worker process can start it. For example, in the start serving web server method of master process, the Prometheus handler is added to the web server. Then we can access the specific location of master web server. Then we can get the metrics in the format of Prometheus. Okay, so far we have figured out the difference between these two kinds of things. So now we can try to implement our own thing. The first thing we need to do is to determine which kind our think belongs to. Is it a passive think or active think? For example, if we want to implement a XML think of Alluxio, which prints the matrix to a specific path, so what we should do is active think, right? So just like the console think, we need to implement the think interface. Also, we need the XML reporter to report the matrix periodically. Then we just need to tell the scheduled reporter how to print the matrix in XML format. So then we get a custom think. After that, we need to enable our think by adding XML think class we just defined to the matrix properties. In addition, we can add some properties to our think in this format. Now, this is how to implement an XML think is active think. Similarly, if you want to implement a passive think, you can refer to the JSON think or the Prometheus think. Okay, then it's the last part, how to set up a monitoring for Alluxio in 10 minutes. We can access the metrics tab of Alluxio Web UI to monitor the state of Alluxio cluster and get some key information of Alluxio. It's really convenient, but sometimes it doesn't work so well. Like the screenshot shows on the right, the dashboard is puzzling, right? Besides, if we want more information about Alluxio, or if we want more virtualized dashboards, what we should do? Obviously, we need another monitoring solution, right? And it may need some extra works. This is our monitoring solution. We can see that we use the Prometheus think to bridge the Alluxio and Grafana, because both Alluxio and Grafana have a good support to Prometheus. So how it works? Firstly, Prometheus grabs metrics from Alluxio service and transforms to time series dates and store them. So then the Grafana server can get this time series date from Prometheus. Then Grafana Web UI can display its metrics in dashboards. This is how it works. And then what we need to do to set up this monitoring, we only need 4 steps to set up such a monitoring, and don't need much effort. Firstly, we need to install and start the Prometheus and Grafana server. It's quite simple to follow the according tutorials, and just using the default configuration is enough. Then we need to add our Alluxio jobs to Prometheus. Then Prometheus can find our Alluxio service and scraps the metrics automatically. Then in the Grafana part, we offer a Grafana dashboard template, so we can reuse it to quickly set up an Alluxio dashboard. So the step 3 is to download and import the dashboard template. Lastly, we modify the variables of the template to make it our own dashboard. It sounds quite simple, right? Then I'll show you a demo video about how to import the dashboard template. Before that, we need to add the Alluxio jobs to Prometheus. This part can be found in the Alluxio documents, the metrics section. Now we add 2 jobs in Prometheus configuration file. One is Alluxio master, and another is Alluxio worker. The job names we need to import the job names we need to use to import the Grafana dashboard. So we need to keep in mind of the job names. And this is the versions of the components in the demo video. The Alluxio version is almost a native version, so do not worry the version compatibility problems. And these are the services I set up in the demo video. Because there are two nodes in my cluster, a worker node and a master node. I put the service in different nodes, so we need to notice this point. But it's not important. We only need to know the import process. Okay, I'll show the demo video. Okay, this is the homepage of Grafana Web UI. It works at the worker node with the default port. Then the first thing we need to do is to add a data source. We need to add our Prometheus data source. The Prometheus works at the master node, so we just fill in the master and default port 1990 here, and click the save and test button. We can see it works well. Then we need to import the Grafana dashboard template. I have uploaded the template to the Grafana cloud, so we just need to copy the ID and fill in here, then click load. We now need to choose our data source added before and modify the variables. Remember the job name in Prometheus, put them here and change the user to the actual user, then click load, click import. Now we get the whole dashboard with plenty of panels. Let me change the sample scale to last 5 minutes because the Alluxio cluster has not been running for a long time. The panels are classified into different roles. For example, this is total number of bytes short circuit read from local storage by all clients, and this is workers space used information and some other panels. This no data is normal because no operations, no metrics. Okay. Lastly is message-driven memory. Lastly, do not forget to save your dashboard. Okay, then we got the dashboard. In fact, the import process only takes 2 minutes, right? And these are the screenshots of monitoring. There are 8 live workers in the cluster, and the monitoring system works well. You can see the matrix is in different panels. These are the labels in the dashboard of different rows. So if you want to add or remove some panels, you can just operate on the dashboard. It's quite simple and convenient. The monitoring solution can be found in the Alluxio documents here, and this is the dashboards template. Okay, that's all. I hope this talk is helpful. If you have any questions, feel free to mail me. Thank you.